Ladies and gentlemen, welcome back to the channel. Thank you so much for being here. As always, today we've got an awesome video. Pi Lanningham, one of the core team members at SundaeSwap in the Cardano ecosystem, is here to talk about the UTXO model that underpins Cardano, specifically the extended UTXO model and how it compares to an account-based model like Ethereum. We're going to dive deep today, so let's go ahead and jump in.
Hey, Hashoshi, thanks for having me on. I kind of am excited to share some of the ways that we've been thinking at SundaeSwap about like Cardano's design and which aspects of it are important, right? And which ones, there's a lot of really nitty-gritty details if you go dive into the papers, and some of those are important and some of those aren't. And so I kind of wanted to give your viewers that technical deep dive that maybe they've been hungry for on maybe you're not able to kind of go and read those really, really dense papers. And you kind of just want to know, at a higher level, how does the eUTXO model work and stuff.
Awesome.
Yeah, so I'm going to go ahead and share my screen. And feel free to, throughout this, stop me, ask questions. This is really very casual. It's just kind of a back and forth. Does that make sense?
Yes, sir.
Cool. So I want to frame the discussion first by a point of comparison, right? Let's talk a little bit about how Ethereum thinks about transactions. I'll say I'm not an Ethereum expert, so some of these details may be wrong, but just as a point of comparison, it's good to know at least a basic framework of how Ethereum works, right?
Yep.
So in Ethereum, there are, like in any blockchain, there are a series of blocks. The blocks contain the data for all the transactions that happen. And then each block refers to the previous one. And the thing that kind of is important to think about is how are these transactions represented? What do they do? And how are they processed, right? And so kind of in a basic way, each transaction is, like a function call, right? So it transfers some amount of value, but it also can optionally say, call, function foo with parameters A, B, and C. And then this is some code that gives step-by-step instructions for what to do with your money, right? So this might say, if A is greater than 10, abort. If, otherwise send, B ETH to address C.
Yep.
Right. So these are very a procedural description of what to do. The soundbite that I've been using is Ethereum gave money legs and Cardano gives it preferences. And so that'll make more sense as I get into how Cardano works. But what I mean by that is, this gave your money legs. You hand over some of your money to this code, and then the code decides what to go and do with it, right?
Right.
And if there are multiple of these function calls in either one transaction or in multiple transactions, they're all processed kind of sequentially, right? So there may be one large block like this, and within it, we process each transaction one after the other. And each one can go and do some of this procedural code. And each one, if we think about the kind of memory, the state, the values that we've written down, to the notes that we've taken for ourselves in our smart contracts, as this virtual memory, each one of these, and I'm going to switch colors, each one of these can go and update some little state here, right? And so then this one might go and update this. And this one might depend on the state that we updated in a previous transaction. And that's why everything has to be processed in a row, rather than an alternate model you might imagine where we just say, okay, well, everything in a block, let's just process the transactions in parallel, right? Like, why can't we do that? And then the blocks could be much shorter, right? I drew this very big, but like we could uh, process the blocks much quicker if we were kind of able to multi-thread them. And this kind of crossover is exactly why we can't do that, right? So the results and what this transaction does may depend on this little piece of memory.
Right.
And so if we wanted to process these, we'd have to have some kind of complicated tracking where we knew every little bit of memory that this was going to touch, which may be a very hard question to answer, and then say, okay, well, you can process anything in parallel to this that only touches different pieces of memory, right? And just given the way that Ethereum is designed, like theoretically, you could do that with like static analysis and stuff, but it'd probably be so expensive as to not be worth it, right?
Right. You'd always be chasing as well because things move so fast. You know, there are people who try and sort of front run DeFi by doing deep analysis of the queue of transactions and like the mempool.
Yeah,
And
absolutely.
it works, but it's an arduous task, no doubt.
Absolutely. And so this is, you know, it's kind of it's ironic to me that people kind of point at Cardano, and we'll talk a little bit about this later when I get to Cardano, but point at Cardano and say, oh, well, Cardano isn't concurrent, when fundamentally, right, Ethereum is as, you know, serial and as single threaded as it can get. And it kind of has to be that way by design. And a lot of the layer 2 solutions are focused around how do we introduce this sharding? How do we introduce constraints on our smart contracts so that we know which portions of the state they might interact with, so that we can start looking at serializing things or parallelizing things. So now I want to talk a little bit about how Cardano works. So Cardano works on kind of a fundamentally different model. Instead of having this big ledger state where kind of notes are taken in memory, those notes are taken right next to, are stored right next to, or bundled with your funds. So every transaction in Cardano, and this will be very familiar to people who are familiar with how Bitcoin keeps track of funds. But every transaction has some number of outputs, right? And so this is just a list. It says, oh, I'm going to output 1 ADA and 5 ADA. And, you know, those outputs in Cardano, kind of in contrast to Bitcoin, can also have other coins, right? So this could be 3 ADA and 2 Sundae.
Yep.
Right? And so when you're constructing another transaction, the way that you declare what funds need to be spent is by listing out the inputs that you're consuming. Over here, you declare which account you're spending from, right? So you say, okay, from this address, deduct 1 ether and increment this address by 1 ether. Down here, you say, okay, well, I was given 1 ADA right here, so include that in my transaction, right? Yep. And so that's what's meant by, you know, you hear this term thrown around, UTXO. That's unspent transaction output. So once this has been included in another transaction, it has been spent. So this U goes away. So, you know, we can basically forget about this, right? We can, it becomes historical information, and we don't have to kind of keep it in memory as your wallet balance, so to speak.
Right. Yeah.
So this is the UTXO model, and it has a number of advantages. In particular, if we look at 2 transactions, right? These two transactions, one that consumes this 1 ADA input and one that consumes this 5 ADA input, right? And oh, this would have to have an output with whatever you're doing with it, right? So maybe 1 ADA sent to someone else. And this one maybe is 2 ADA sent to somebody and 3 ADA sent back to you, right? If we look at these, we can validate that these transactions are correct in parallel, right? They don't have any dependency on each other. And the result of validating one can't depend or can't be affected by the other. And what do I mean by validate here? So in just the simple UTXO model, that means is the total amount of ADA coming in the same as the total amount of ADA coming out, right?
Foundational.
And similarly, does it contain all of the signatures for the owners of the inputs, right? So if this is 1 ADA owned by Pi, and this is 5 ADA owned by Hash, then my private key signature has to be included on this transaction, and your private key signature has to be included on this one, right? That's how we validate that you are indeed allowed to spend those funds. So we can validate those in parallel, and it's basically an explicit declaration of what you depend on, right? So up here, I said that the reason this was difficult is because we can't track all of the different kind of branches of this code and what little pieces of memory they might be dependent on. In this, again, just the simple UTXO model, well, we've explicitly declared the funds that we're dependent on. And so we can know very intuitively and very quickly whether they depend on each other. Well, do they use funds that come from their output, right? From each other's output. So I'm gonna pause here and add a disclaimer in that, I think if you go and you dig into the Cardano node source code right now, they are not doing this verification in parallel. They still process them one by one, and that's because the volume on the node, it's far simpler to implement it as a serial processing. But what I'm doing here is emphasizing the potential, right? As the Cardano network grows and it needs more scalability, they can implement far more sophisticated kind of transaction selection and transaction processing techniques.
Right. Makes sense. I mean, and you look at the Ethereum model and the UTXO, like the account-based model and the UTXO model, and there's very clear like delineations as to the way that they approach the issue, not only of transaction validation by balance, where you have one that's like almost like a true ledger-based accounting, like a bank or an accounting ledger, and the other in the UTXO space almost behaves more like, cash and change, where you have to denote, hey, I'm going to give you a $20 bill. I need 5 back. So you're defining very clearly the results of each transaction. So that's what I think folks can take away is, at the very base layer, the transactions themselves behave differently in the data they're in, the state, the underlying state. And so therefore your approach to smart contracts and other things become very different as well.
Yeah, absolutely. And UTXO does have its own downsides as well.
Right.
So one of the things that's way more complicated in this world is that determining your account balance is more complicated, because you have to say, okay, well, I have this collection of different kind of piles of change, and I have to add it all up. It's not particularly hard, but it is more complicated than just reading off a number. Similarly, when you are building a transaction, or this is something that plagues wallet developers and dApp developers, you have to make an intelligent selection of these UTXOs, right? If I need 20 ADA to cover the cost of whatever I'm doing, that may be split across 6 different UTXOs. And that means my transaction fee is going to be slightly different depending on which ones I select. That means that depending on which ones I select, I'm going to have I'm going to kind of fragment the chain more, right? Because if I select the wrong one, and there's a minuscule fraction of an ADA left over, well, that creates a much smaller kind of concentration of ADA, meaning a bigger mempool size for the validating nodes. And this UTXO selection algorithm can get quite complicated.
Mm-hmm.
So as an engineer, I'll never say, oh, this is just fundamentally always better than the accounting-based model.
Oh yeah.
But it is, there are trade-offs, and the hypothesis put forward by IOG is that for a layer one solution where you need global scalability, you need to fundamentally bake in this ability to shard and this ability to say, okay, well, the underlying data is sharded, so when we need to shard to layer two solutions, it's very natural, as opposed to a lot of really clever engineering that needed to, and complicated engineering that needed to go into all of these other L2 solutions on Ethereum that are figuring out how to shard an account-based model now, after the fact, right?
Right.
Okay, so that's UTXO, and that was popularized by Bitcoin. Let's talk about this little eUTXO. So this E stands for extended. And so they're basically saying, okay, well, we like a lot of the properties here, but how can we extend it to introduce smart contracts? In retrospect, it kind of looks obvious, but let me emphasize, it took, many years for people to figure out how to do this, because, they've been trying to add smart contracts to Bitcoin for a while.
Mm-hmm.
And doing so in a way that preserves the soundness is really tricky. And so this is quite an elegant solution to that problem. And so there are three main ways in which we're going to change this model. So I want to emphasize those. So first is we need a place to store data, right? One big thing about smart contracts is that they store data on chain. And so they I'm going to pause and reset and have you cut that out, just because I lost my train of thought.
No problem.
So one of the first things that we need to do to kind of add smart contracts, and one critical piece of smart contracts, is data, right? I need to store what the current price of something is, or I need to store the random values that I'm going to use for my lottery function, or I'm going to keep track of how many NFTs in the collection that I've issued, so that I don't over subscribe that NFT, and things like that, right? And so the place that they store that kind of data is as an extra field on the output. So when I construct a transaction, my output, it now has the value that is attached to it. So that's 1 ADA and 3 Sunday and 4 LQ, or whatever it is. And it has the owner. And this is another piece that's going to change, but I'm not going to talk about that yet. And it has the datum. And specifically, it has just the hash of the datum, right? Because the datum might be very large, and in some protocols, you might want to keep that datum secret until it comes time to spend it. So you hash any data that you want to kind of record permanently on chain, and you include that datum hash. Now, optionally, depending on your protocol, you can include the full datum kind of here in the footer of the transaction, so that other people can look that up and say, okay, well, if this is tracking the state of a liquidity pool, it doesn't do us much good to have to broadcast that new state to everybody, so I can optionally include it. But if this is instead some kind of private auction, then I can leave that datum off and only include that datum when I go to spend the transaction. And so that's a good place to talk about. So up here, I talked about you have to include this private key or this signature from your private key in order to spend the transaction. We call that a witness, right? It's kind of, if we think about the analogy of proving that I am allowed to spend these funds, I provide my signature, right? It says, oh, I'm proving that I am indeed the owner of these. So that goes in this witness set. Similarly, when you spend one of these transactions, you have to include a witness for the datum. So you say, okay, well, here is the datum that hashes to that value. I am proving that that's what that data is.
Easy to
right?
validate that. Yep.
Yeah. And so the validator node will say, okay, well, does the hash actually match? And if not, then the transaction's invalid and it rejects it. If it is, then it proceeds to the next step. So that's the first thing that we include, right? That is, if we're going to go back up to the Ethereum model, that represents this. Okay.
Right.
The next thing that we need to include is a way to tell the smart contract what needs to happen, right? The input parameters to the contract. And so that is called the redeemer. And so on this bridge where I say, I'm consuming this input, I can include a redeemer. And that's just a little piece of data, and that corresponds to, spiritually, this
Arguments
on Ethereum, right? And so it's the input arguments to your smart contract. So for example, if you have funds that are locked up and vesting over like a vesting schedule, then the different redeemers you might include are, oh, I am claiming my vested rewards as an employee, and then the smart contract is going to do one thing, or this employee has left, and as the company, I'm clawing back those funds, right? And so that might be a different redeemer, and then the smart contract is going to do a different thing. And so the redeemer is kind of, it controls the behavior, and it controls the exact settings of that behavior. Now, the final thing that needs to be changed is we need a place to put, like, what does it do, right? And this is where this is probably the biggest area where it differs. And so where that is stored is here on the owner, right? And so previously, this would be the hash of someone's public key. So if my public key was 1EF ... right? And there I had some private secret key that corresponded to that I could sign transactions with, then the owner, your address, right? This is fundamentally what an address is the Blake B52. I may be getting the name of that wrong, because now I'm just thinking Blake 152, but but the Blake B52 hash of your public key, and that is the ADDR153 blah 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 that like you give somebody to send you funds.
What you're used to, yeah.
Right. We're going to extend this to also allow the Blake hash of code, and that will produce ADDR31E ... And then, in order to spend these funds, well, I have to prove that I have the rights to do so. And so I provide a witness, which is the source code that does indeed hash to that. And so that allows you to, you can define the criteria under which these funds get spent. Now, if you remember up here, I talked about how, Ethereum gave money legs. It explicitly tells you what happens with your money. It says, there is a portion that is saying, okay, here are the conditions under which this is valid. But it also includes a description of what to do with it. And there's not really a notion of that in Cardano. It is purely these conditions for spending. So that means that you say things like, okay, you can spend these funds if this much time has elapsed and you are spending them into, the employee's account, and the redeemer is the claim option, right? And so that's a simple vesting contract where, okay, well, if that much time hasn't passed, the transaction gets rejected. Or if you try to spend them to somebody else, well, the transaction gets rejected. Or all these different conditions.
Right.
Something like a DEX might say, okay, you're allowed to spend this huge aggregation of funds and withdraw, some ADA, as long as you're putting in some amount of the other half of the pair, right? And so really the calculation, or the decision of what happens falls on the transaction builder, the person who's putting together the bytes for the transaction, right? And so this here, where it says, oh, send this much money to an address, that is on the, and this is where you hear the on-chain versus off-chain. It's on the off-chain code, the transaction builder, to describe that, to actually do that, so to speak, in their outputs, to include an output addressed to, the parameter from the redeemer. And it's on the on-chain code, the script, to say, is that valid or not?
Right. And that's the key difference, right, between the two models is, way back, I think there's been a lot of content created about the sort of paradigm differences between the two. One gives you a lot of room. So on Ethereum, what that smart contract outlines is how to do each thing, and specifically the steps that it needs to take, which obviously allows you to do a lot of really cool and interesting things, but also gives you a lot of opportunities for side effects and unintended consequences if you don't handle edge cases and indexes, especially where prices are changing. That's when you get some of these extra issues, the impermanent losses and slippages of the world. And with Cardano, I mean, the way that you described it, even, you're listing out not necessarily how to do something, but what to do specifically. And it gives you very predictable results, and you can be relatively sure that you're not going to have the contract or the transaction behaving in a way that you didn't expect.
Yeah, and specifically, just to draw a fine point on that, as the transaction builder, which is usually the dApp, right? Like the web interface to interact with a decentralized protocol will build this transaction for you, right? We're not expecting end users to go in and say, okay, well, byte 53 needs to be this, and byte 54 needs to be this, right? And so it's on the dApp to declare, right? It's very declarative. They are declaring what the output state is. That is then presented to the user through the wallet interface, and they say, okay, yeah, I'm okay with those outcomes. And then they commit their signature, their witness, to the hash, saying, yeah, you can spend my funds if this is the outcome. So it's far more deterministic, right? Like one way to look at this is that when I construct a transaction to submit it to the blockchain in Ethereum, I'm giving up control. I'm saying, okay, this is the impulse. This is what I am giving my authority to spend my funds as long as you're calling this function. But there's no way for you to know what the outcomes are, right? You could look at the state of the blockchain and say, okay, if I ran it right now, this is what the outcomes are going to be. And so I'm okay with that. But because like the speed of light is a thing, and because the blockchain is moving, and a different set of transactions, even within the same block, may have been processed before yours. And thus, the state, the input state, may be different than what you expected. That transaction can do something fundamentally different, right? Maybe there is a piece of code here that says if this piece of memory is greater than 10, then sneaky hack, like send all my funds to the dApp builder. And when you run the transaction, well, this is 9, and so it doesn't do that. It does what you expect it to do when you check it locally, right? But by the time your transaction has been submitted and slotted in way over here, many other transactions could have run, which changed this value to 15, and now all of a sudden you lose your money, right? And so a huge amount of the development effort and attack surface area is in the cleverness of the smart contract writers to make sure that they, by the time they're executing, they're still operating in your best interest, right? And kind of faithfully executing what you wanted to happen. And because they are devoting that effort here, they still deserve to be compensated. And so that's why, like, if your transaction on Ethereum aborts, you still have to pay the gas fees, right? Because they still did some work.
Yep.
Down here on Cardano, because you're explicitly declaring the outputs, well, and the inputs that you depend on, it's still possible for the state of the world to change out from under you, right? Somebody could have spent this UTXO in a different transaction. But if that happens, the validator node, the block producing node, has to do far, far less work to reject your transaction. And so you don't lose your gas fees, right? And so that's a big benefit of Cardano. And there's a lot of blood spilled, so to speak, on this concurrency issue where, okay, yeah, if there is this global state here, Cardano is not designed to allow you to give up control enough to say, okay, well, just go and pick a different one for me, right? Go pick a different UTXO. I trust you to do the right thing. It's really trying to make sure that you know the consequences of what you're doing. Now, in an abstract sense, it depends on how well the wallet communicates this information, and that's a huge UX problem we have to solve as a community. But in principle, if something about the state has changed in a way that would change the outcomes, the transaction is rejected, my fees aren't taken. And that's a really important and critical property of the eUTXO model that doesn't get talked about as much. And the hypothesis put forward by IOG, and that like we in the Cardano community believe in, is that for a layer 1 solution where you're going to be trading houses and like settling accounts on like a global scale, that's a really important property. And so if in the future you shard off pieces of this and then you have a faster or more trust-based accounting model where you can give up control of your funds to the DEX and say, okay, yeah, SundaeSwap, you've been operating honestly for years, your code is all audited, there's been no major hacks, I want to give up trust to you, and we're going to potentially operate in like a Hydra head that has a different accounting model to enable that kind of operation. That's possible, but the base chain where there is kind of as little trust as possible has this key fundamental property.
Right.
So that's, if I was giving somebody a deep dive on the eUTXO model, that's the material that I would cover, and the kind of key important differences that I think about with Cardano versus Ethereum. Do you have any questions before we close out this section?
I think the only question that I would anticipate that folks that are watching might have as they think about this is, generally as we move maybe towards solutions and how SundaeSwap works in the context of Cardano, where is
where is the delineation between concurrency and parallelization that helps you achieve those things, and how does that relate to the UTXO model that's here? And I think that the big challenge is that it's hard for someone to independently validate claims that might be made on social media,
Yeah.
ad hoc, about how these things work and what the implications are of these design decisions. But I think overall, right, this is a great primer for folks that might not have already been aware of the differences fundamentally between the two.
Yeah. And to talk about that at a high level, we wrote an article that kind of explored that, and we'll kind of explore that um, in the future when you and I sit down to talk about how our scaling solution works.
Mm-hmm.
But the the kind of fundamental thing here is that um, anytime on Cardano you have some piece of global state that
Mm-hmm.
everybody needs to interact with, you're going to have this contention problem, right?
Mm-hmm.
At least on the layer one solution. And so there there are a number of ways that concurrency can come back into the system.
Mm-hmm.
Um, the first one is to note that this only applies to a single DeFi protocol. Two different protocols are going to have their own pieces of global state,
Mm-hmm.
and so they can operate completely independently, whereas and in parallel and concurrently. Whereas up here on Ethereum, every transaction, regardless of the protocol, needs to be executed one after the other, right? So there's like a fundamental limit in the serializability of these transactions. Whereas on Cardano, even in kind of that worst case scenario, like we saw in kind of uh, some of the high profile criticism over the last few weeks, different protocols are still operating more concurrently and more in parallel than on Ethereum. The second way is that many DeFi protocols don't need that kind of global state, right? Something like Liquid, which is just allowing you personally to lock up funds and borrow against them, needs far less global state, and that global state, is not or not as time critical, right? Like they can afford to have a piece of global state that is the kind of pricing of each thing and the collateralization efforts, but then like split that into many different copies of that each person can interact with individually, right? They are less timing sensitive to that. Something like a DEX is a much trickier design problem because
Yeah.
fundamentally you have a very timing sensitive global state that everybody wants to interact with, which is the single kind of aggregation of funds for a liquidity pool. And so there are ways to solve that, but you know, uh, it is not widespread as widespread as you might have been led to believe. It just applies to really kind of certain types of protocols.
Right. Yeah. And I think that's critical to note. I mean, throughout this whole conversation, I think it quickly on social media and maybe in other areas of the media in general, it quickly devolves to a, you know, unilateral, this is better than this and vice versa. Whereas it's two different models that are really good and really effective at different things and also have key benefits and, of course, minor detractions that make it more difficult to work with in some scenarios or have, there's always going to be trade-offs. And so from a development perspective, it's picking the right tool for the job and looking at the environment that you have and working with those tools, understanding the limitations and understanding the things it does really well and to optimize, right?
Yeah,
That's the goal.
yeah, and in particular, also picking the tools that allow you to remain flexible to use other tools in the future, right? Like
Right.
evolution didn't give us hammers for hands because like while hammers are useful, right? And you wouldn't want to hammer a nail with, what evolution did give us.
Yep.
These are far more flexible in allowing us to use other things down the line. Now, I'm not saying evolution consciously thought, whatever, but
Yeah.
in terms of the flexibility, right? There some of those decisions and the hypothesis and the kind of declaration that Cardano is making is that the eUTXO model is the more flexible option that opens up more doors down the future for specialization. And this is what Charles talks about with like, the computation layer versus the settlement layer, and how Hydra is going to allow you to kind of shard off and have different computational and accounting models in a way that isn't going to kind of come back and impact the designs or the stability of the outer chain.
Right. Knowing the end from the beginning, and knowing where you're going so that you can set yourself up for a good foundation.
Absolutely.
Yeah, makes perfect sense. Pi, I really appreciate you sharing this. I think this will be really helpful for folks that are, looking at a non emotionally charged comparison between the underlying models behind Ethereum and Cardano, understanding where they have value, how they generally work, and how that leads into some of the solutions that we're going to see. So really excited to have that conversation as well around SundaeSwap's secret sauce.
Yeah, and thanks for having me on. I really enjoy. Obviously, if it wasn't obvious, I really enjoy this kind of stuff and being able to kind of get into the nitty gritty details.
Absolutely, it makes my job super easy. All I have to do is set you loose, and you'll walk everybody through it. So thank you so much again, and we will definitely check in soon on some SundaeSwap specifics.